In part B, we will calculate the interval from 0 to 3 of x cubed minus 6x, the function dx. We will use the theorem number 4, and we calculate the sum of the theorem of the function f of xi times delta x, that is the height times the width. And we notice that we need to calculate the delta x first, right? So delta x is b minus 8 over n, so 3 minus 0 over n is 3 over n. And then the xi, so we will have the interval from 0 to 3, and the x0 is x0, and then x1, and then x2, and then x3. So we have 0 for x0, then to get x1 we will add 3 over n, and we keep adding 3 over n, 9 over n, and so on. Okay, so in general the xi is 3i over n. Okay, so we have the limit when n approaches to infinity of the sum I go from 1 to n of the f of xi. So this is the function f. We will plug into this function. So 3i over n cubed minus 6 times 3i over n, and then times the width is delta x 3 over n. So simplify this integral. So we have the sum of, so we have 27i cubed over n cubed minus 18i over n, and then times 3 over n outside. If we want, we can distribute the 3 over n. So distribute this, so we get 81i cubed n 4 minus 54i over n squared. We keep in mind that the I cube and the I, they are the variable. The rest is not. So we can plug in the formula. So let's rewrite it. So we have 81 over n4 times I cube minus 54 n squared times I. And we will look at the formula number 5. I write out the formula first, and then I will show you. Of I is n times n plus 1 over 2. And look at the formula number 7. So we have n plus 1 over 2 square. Okay, so let's look at number 5 and number 7. Formula on the top right here. So I copy those formula. Okay, we're going to plug in for the I cube number 7. So we will have limit n go to infinity of sum I equal to 1 of 81 n to the 4 times I cube is n plus 1 over 2 square minus 54 over n square times I, and the formula is n plus 1 over 2. Okay, so we can simplify a little bit. So you can pull out the number 2 here. It will become 4. So 81, 4, and then n to the 4th. And for the n plus 1 left, we copy this down. And you can distribute if you want. And that is n squared plus n. minus, we can cancel out the 54 and 2. That gives us 27, and then you can cancel out this n, so we get n. So we get n plus 1. Okay, so here this is what we're gonna do. We're gonna look at the highest exponent of the x, which is 2 and 1. I'm gonna multiply by n squared and n squared, and then n and n, and then use this, and then use this. And we don't forget to have the square on here, right? Copy from the previous step. Okay, so limit of n go to infinity, the sum of the function from 1 to n, I from 1 to n, 81 over 4 n to the 4. Now if we use the one that I circled, so we will get 1 plus 1 over n times, so this one will square, and then n squared will become n4 minus 27 over n times this n right here. So I'm going to move to the front and then simplify the one that we circle, so we get 1 plus 1 over n. Okay, we have a lot to simplify in this step. So we can cancel this out, n4 and n4. And we got n go to infinity, so this part will go to 0. So what we have left is parentheses, so square, 1 square is just 1. So we will have left with 81 over 4. And we can cancel this n. And 1 over n go to 0 when n go to infinity. So the parenthesis is 1. So 27 times 1 is 27. And we will get negative 27 over 4 and give us negative 6 over 75. So from part A and part B, we are working on the same problem, but we are calculate the exact value in part B. So this is the exact answer. And in part A, we have the answer a little bit different, much different than part B. This is called the estimate using the Riemann sum. In later, we will have the way to calculate shorter in part B and get the answer like in part B, but shorter.